code! Hurry.
Hello, I'm Dr. Cody.
And I'm Dr. Nick.
And today we will be talking about the Leidenfrost Effect.
So, all we need for today's experiment is a hot plate and some water. We also have a thermometer here to keep track of the temperature during the experiment and some insulating gloves for protection.
Nick, I believe you forgot something.
No, I think I got everything.
Turkey baster!
Good.
Water has a boiling point of 100 degrees Celsius. This is when water makes the phase transition from its liquid to gaseous state. Higher temperatures will increase the rate of evaporation. What we are seeing right now is water instantly boiling and turning into steam as soon as it contacts the hot plate. However, once a sufficiently high temperature is reached, we'll start to see an interesting phenomenon occur. This graph shows the rate of heat transfer versus the temperature for water. As the temperature increases, the rate of heat transfer also increases until it reaches a critical point. After this maximum, the rate of heat transfer begins to fall until it reaches a local minimum. This minimum is called the Leidenfrost point. Let's take a look at what happens when we put some water on a surface that is heated above this critical temperature.
Even though the plate is now 100 degrees hotter than in the last video, the water is no longer instantly evaporating. This strange occurrence is called the Leidenfrost Effect. It appears that the water is gliding around with no friction, as though it is no longer touching the surface. There is no steaming coming off the water either, implying that something is thermally insulating the droplets from the hot plate. What could be responsible for this strange occurrence? What is actually happening is that the plate is evaporating the water before it even has the opportunity to land on the surface of the hot plate. The water vapor creates a thin layer underneath the droplet which supports it and keeps it levitating just above the hot plate's surface. Since heat transfers much slower through a gas as compared to a liquid, the droplet is effectively insulated from the plate. The layer of gas has virtually no friction with the surface, which allows the droplet to glide around. The temperature at which this occurs varies greatly with the size of the droplet and material of the surface, but for water occurs normally at temperatures above 193 degrees Celsius.
Unlike many of the strange properties of condensed matter, which involve high temperatures and strange conditions, the Leidenfrost effect is a common occurrence in day-to-day life. In fact, it's been known to us for hundreds of years. Johann Gottlieb Leidenfrost discovered it in 1756. It's even common in everyday kitchen activities. Let's take a look at what Chef Cody's cooking up.
Welcome to the kitchen. Today we're going to be cooking some beef with some Mexican spices. And to start, we're going to have to heat up the pan to a very hot temperature. Now, like most master physicist chefs, I use the Leidenfrost effect to determine how hot my pan is. Now, let's take some water. Bam! There's the Leidenfrost effect. I know my pan is nice and hot.
Hey guys, thanks for watching our video. I hope you enjoyed it. Hope you learned something along the way.
Please leave us a like, and if you have any questions, feel free to leave them down in the comment sections.
Alright, thanks guys.